Dear students, welcome to the session 2 of Unit 4, that is Basic System Models and Control Systems. Before going into the topics of the session 2, let us recall what we have studied in the last session. So in the last session, we studied about the system. System is a group of elements which act together to get the desired output. System approach is a methodology which is used to study the system as a whole. Model is a hypothetical description of a system. Mathematical model is a precise model which describes a system very precisely by using mathematical equations. Building blocks are the elements or subsystems or components of a system which put together constitute a system. So under categories of system we have ideal system. Ideal system is a system in which input energy is equal to output energy. That means there is no loss of energy in the process in between input and output. And we have other systems like mechanical system, electrical system, thermal system, hydraulic system, and so on. So in this session, we are going to study mathematical model for mechanical system building blocks, that is spring, dashpot and mass. So mechanical system has the basic building blocks of spring, dashpot and mass. Mechanical systems are assumed to consist of a spring, a dashpot and a mass. So it means any mechanical system need not have spring, it need not have a dashpot and it need not have a mass, but it will have the effect of spring, it will have the effect of a dashpot and it will have the effect of mass. Spring represents the stiffness of a system, dashpot represents the forces which oppose the motion, either frictional or damping effect. Mass represents the inertia or resistance to the acceleration. So mechanical system has the properties of stiffness, damping and inertia. So all these three building blocks can be considered to have force as an input and displacement as an output. The mechanical system na spring, dashpot ಮತ್ತೆ ಮಾಸ್ ಇವುಗಳನ್ನು ಒಳಗೊಂಡು ಮಾಡಿರಲಾಗುತ್ತೆ. ಸೊ ಮೆಕ್ಯಾನಿಕಲ್ ಸಿಸ್ಟಮಲ್ಲಿ ಸ್ಪ್ರಿಂಗ್ದ ಎಫೆಕ್ಟ್ ಇರುತ್ತೆ, ಡ್ಯಾಶ್ಪಾಟ್ದ ಎಫೆಕ್ಟ್ ಇರುತ್ತೆ ಮತ್ತು ಮಾಸ್ದ ಎಫೆಕ್ಟ್ ಇರುತ್ತೆ. ಸ್ಪ್ರಿಂಗ್ ಅಂತಂದರೆ ಸ್ಪ್ರಿಂಗೇ ಇರಬೇಕಂತೇನಿಲ್ಲ, ಸ್ಪ್ರಿಂಗ್ ಆ್ಯಕ್ಷನ್ ಏನಿರುತ್ತೆ ಸ್ಟಿಫ್ನೆಸ್ಸು ಆ ಮೆಕ್ಯಾನಿಕಲ್ ಸಿಸ್ಟಮಲ್ಲಿ ಸ್ಟಿಫ್ನೆಸ್ ಇರುತ್ತೆ. ಡ್ಯಾಶ್ಪಾಟ್ ಅಂದರೆ ಡ್ಯಾಶ್ಪಾಟೇ ಇರಬೇಕಂತೇನಿಲ್ಲ, ಡ್ಯಾಶ್ಪಾಟ್ದ ಎಫೆಕ್ಟ್ ಏನಿದೆ ಅಂದರೆ ಫೋರ್ಸ್ ವಿಚ್ ಅಪೋಸ್ ದ ಮೋಷನ್. ಸೊ ಮೋಷನನ್ನು ಅಪೋಸ್ ಮಾಡುವಂಥ ಫೋರ್ಸ್ ಏನಿದೆ ಫ್ರಿಕ್ಷನಲ್ಲಿ ಇರ್ಬೋದು ಅಥವಾ ಡ್ಯಾಂಪಿಂಗ್ ಎಫೆಕ್ಟ್ ಇರ್ಬೋದು, ಅದು ಆ ಮೆಕ್ಯಾನಿಕಲ್ ಸಿಸ್ಟಮಲ್ಲಿ ಇರುತ್ತೆ. ಹಾಗೆಯೇ ಮಾಸ್ ವಿಚ್ ರೆಪ್ರೆಸೆಂಟ್ಸ್ ದ ಇನರ್ಷಿಯಾ ಆರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಟು ದ ಆಕ್ಸಿಲರೇಷನ್. So let us study one by one. Let us take up spring to begin with. These are the various types of springs. So when spring is subjected to force, it may be either compressive or tensile. It is either compressed or stretched respectively. Now if we consider a linear spring, if F is the force applied, X is the displacement, so then F is directly proportional to X. F is equal to Kx, where K is called the spring constant or stiffness of the spring. So F equals Kx, this is called mathematical model of the spring. So when force is exerted on a spring, it stores the energy in the form of potential energy. So according to Newton's third law of motion, spring also develops an equal and opposite force to the external force. So when force is applied, so it exerts opposite force equal to the force applied. The proportionality constant K that represents stiffness of the spring, K is equal to F by X. So it means higher the stiffness of the spring, more will be the force required to deflect it. So more the stiffness of the spring, more force is required to deform it or compress it or stretch it. So mathematical model of the spring ಅಂತಂದರೆ F equals K by X, ಇದನ್ನು ಗಣಿತದ ಮಾಡೆಲ್ ಅಂತ ಕರಿತೀವಿ ಸ್ಪ್ರಿಂಗ್ದು. ನಾವು ಫೋರ್ಸ್ ಏನು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ ಸ್ಪ್ರಿಂಗ್ಗೆ, ಅದು ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆಗಿ ಸ್ಟೋರ್ ಆಗಿರುತ್ತೆ ಸ್ಪ್ರಿಂಗಲ್ಲಿ. ಸೊ ನ್ಯೂಟನ್ಸ್ ಥರ್ಡ್ ಲಾ ಆಫ್ ಮೋಷನ್ ಪ್ರಕಾರ ಏನಾಗುತ್ತೆ, ನೀವು ಯಾವುದಾದ್ರೂ ಫೋರ್ಸ್ ಅಪ್ಲೈ ಮಾಡಿದರೆ ಆ ಸ್ಪ್ರಿಂಗು ಆಪೋಸಿಟ್ ಫೋರ್ಸನ್ನು ಅಪ್ಲೈ ಮಾಡುತ್ತೆ. ಸೊ ಇಟ್ ಡೆವಲಪ್ಸ್ an opposite force when force is applied on the spring. So that force is equal to the applied force. So that is as per Newton's third law of motion. The K ಅಂತಂದರೆ ಸ್ಟಿಫ್ನೆಸ್ ಅಂತ ಕರಿತೀವಿ ಇಲ್ಲಿ. K equals F by X. K ಜಾಸ್ತಿ ಆದರೆ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಅಂದರೆ ಸ್ಟಿಫ್ನೆಸ್ ಜಾಸ್ತಿ ಇದ್ದರೆ ಆ ಸ್ಪ್ರಿಂಗನ್ನು ಕಂಪ್ರೆಸ್ ಮಾಡೋದಕ್ಕೆ ಅಥವಾ ಸ್ಟ್ರೆಸ್ ಮಾಡೋದಕ್ಕೆ ಬೇಕಾಗಿರೋ ಫೋರ್ಸ್ ಇದೆಯಲ್ಲ ಅದು ಕೂಡ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಸೊ ದಟ್ ಈಸ್ ಆಸ್ ಪರ್ ದಿಸ್ ಮ್ಯಾಥಮೆಟಿಕಲ್ ಮಾಡೆಲ್. So the next building block of mechanical system is dashpot. What is a dashpot? Dashpot represents the types of forces experienced by the system when the object is pushed through a fluid or move an object against friction. So when the object is pushed through a fluid, so it develops a force, it experiences a force, or when it is moved against a friction, so then also it experiences a force. So that type of system is called dashpot. So more the speed of pushing the object, more will be the resisting forces. So faster the object is pushed, greater will be the resisting forces. So dashpot means it consists of a cylinder containing fluid and a piston. So when the fluid is pushed by the piston, so fluid tries to flow out. When the fluid is compressed, the fluid tends to come out of the piston in the opposite direction. So similarly, if the piston is pushed back, the fluid tends to get into the piston, that is cylinder, okay, through the piston and cylinder surface. In the ideal case, damping or resistive force is proportional to the velocity of the piston. F is directly proportional to V. So F equals CV, where C is the proportionality constant. This constant is called damping coefficient. So V can be replaced by dx by dt. Dx by dt is the differential form of velocity, where x is the displacement. When the displacement is differentiated with respect to time, so we will get the velocity. So therefore we can replace V by dx by dt. So F is equal to C dx by dt. So this is the mathematical model for dashpot. So similarly, mass is another building block of mechanical system. Now it exhibits the property that bigger the mass, greater will be the force required. More the mass, more will be the force required to move it, to get the required acceleration. Now as per Newton's second law of motion, F is equal to ma. That is, force is directly proportional to rate of change of momentum. Force is equal to rate of change of momentum. So that can be written as F is equal to ma. So where m is the proportionality constant, that is called mass. So where a is acceleration, the acceleration is obtained by differentiating displacement twice with respect to t. A is equal to d square x by dt square. So acceleration is equal to d square x by dt square. So that is obtained by differentiating velocity once with respect to time, or differentiating displacement with respect to t twice. So F is equal to m into a. A can be replaced by d square x by dt square. So F equals m d square x by dt square is the differential form of F equals ma. So this is the mathematical model of mass. So therefore, to extend the spring or to compress the spring or to accelerate the mass and to move the piston in the dashpot, we require energy. Energy is required. The energy stored in the spring when it is stretched is equal to half kx square. Where F equals kx, therefore x is equal to F by k. So energy can be written as half k into F square by k square. So E equals half F square by k square. This is the potential energy stored in the spring. So for the mass, energy will be equal to half mv square. So where v is the velocity of the object. So E is equal to half mv square is the kinetic energy. Now for the dashpot, there is no energy stored, but it dissipates the energy. Energy is not stored in the dashpot, but it dissipates the energy. So that's why it is called damping. So it reduces the energy, it absorbs the energy or dissipates the energy. It does not return to its original position when the force is removed. When the force is removed, it won't return to the original position. So force withdraw ಮಾಡಿಕೊಂಡಾಗ ಫೋರ್ಸ್ನ ರಿಮೂವ್ ಮಾಡಿದಾಗ ಅದು ಒರಿಜಿನಲ್ ಪೊಸಿಷನ್ಗೆ ಬರಲ್ಲ ಅಂತಂದರೆ ಅದರಲ್ಲಿ ಎನರ್ಜಿ ಸ್ಟೋರ್ ಆಗಿರಲ್ಲ ಅಂತ ಅರ್ಥ. So the power dissipated is equal to P, that is equal to CV square, where V is called velocity of the body, velocity of the object. So P is the power dissipated. Now let us recall what we have studied in the session through multiple choice questions. First question: spring, dashpot, mass, etc. are the building blocks of mechanical systems. Resistors, capacitors, inductors, etc. are building blocks of, obviously it is electrical system. Resistance, capacitance, inertance, etc. are building blocks of electrical system. Spring represents the dash of a mechanical system. Spring represents the stiffness of a mechanical system. Dashpot represents the forces opposing motion. Is a dash effect, that is damping effect. The mathematical model of a spring is given by F equals kx. Mathematical model of dashpot is given by F equals c dx by dt, or it can be F equals cv, where v is the velocity. F equals m d square x by dt square is F equals ma, that is the mathematical model of mass, whereas E equals half m square is the energy, kinetic energy of the mass. Mathematical model of mass is given by F equals m d square x by dt square the power P dissipated by a dashpot depending on velocity V is given by P equals cv square, where V is the velocity, C is damping coefficient. The form of energy stored in a spring subjected to force is dash energy, that is potential energy. So the energy stored in the spring is called potential energy. So that completes this session. Thank you.